Okay, students. Now let's see about the physical system. Physical system. Okay, you know different types of physical systems are there. First one, electrical system. Second one, mechanical system. Third one, hydraulic system. Fourth one, thermal system, etc. Okay, there are many systems, but what we are going to study here is about electrical system and mechanical system we are going to study. Okay, now coming to electrical system. Based upon the type of material, based upon the type of input, okay, this electrical system can be analyzed. First one, it is based upon the type of source. Next, it is based upon the type of element used. Okay, what are the elements that are connected to electrical system? If I say electrical system, you will be having resistor, inductor, capacitor. Source will be voltage, current. Okay, these are the elements. This is the source. If I am using voltage as source, then I will get voltage, source, system. If I am using current, then I will get current, source, system. Okay. Next one is mechanical system. It is classified into two types. They are translational system and rotational system. Okay. If I am saying translational system, three different elements comes into picture. One is mass, spring, friction. Mass, spring and friction are the three different elements. Mass, we are going to represent it as M. Spring is represented as K. Friction is a force. It is an opposing force which is obtained by using a dashpot, and it is represented as B. Okay, this is what we studied yesterday. Okay, now let's start the analysis of mechanical system. Okay, first one, what we said, it is mass. It is represented as M. Okay, mass is nothing but a physical object. An object that has weight, I will call it as mass. Okay, now let us consider a reference. Okay, without giving any force, this mass will not move. Certain case, we will write like this. It indicates that the mass and the reference point is connected. Okay, but you have zero friction here. You have zero friction here. Okay, now what I will do? I will pull this mass by giving a force of F of t. I will pull this mass by giving an input force of F of t. When I pull this mass, we will have a displacement of x of t. So what does it mean? F of t is the input, x of t is the displacement. Okay. Then what is the expression for f of t now? Okay, we know that F is equal to what? Mass into acceleration. Same formula we are going to use here. Now f of t is equal to, this is small f, okay, f of t is equal to mass into acceleration. Acceleration, what is the formula for a acceleration? It is d square x of t by dt square. So that I am going to write here, d square x of t by dt square. Okay, then now this is the formula for f of t. Now everything it is in time domain, but I want it in terms of frequency domain. So I am going to take Laplace transform of that. When I take Laplace transform, f of t will become f of s. Mass is a constant. Then the Laplace transform of this term. Laplace transform of this term is s square x of s. Okay, this is the Laplace transform. So now what you are getting is your final answer for this mass is this one. F of s is equal to m into s square x of s. Okay, this is when one mass is considered. Okay, now if I'm having two masses. If I have two mass, what will happen? How many displacement I will have? I will have two displacement. One mass, one displacement. Okay. In any diagram, whenever mass is there, you have to include your displacement. Now, two mass is considered. See, this is the joining place of the two mass and it is having a rigid body. Here I am going to show some fixed. It is fixed to the reference which I'm going to give. This is my rigid body. Okay. And okay. Now what I will do? I will pull this. I will apply f of t and pull it. Okay. This mass will have a displacement of x1 of t because it is respect to mass m1. This will have a displacement of x of 2 because it is with respect to this mass. Okay. When I pull this f of t, first x2 will come, then x1 will come. So my expression will be f of t is equal to m into, can say me, x2 of t minus x1 of t. But how many masses I have? Two mass. So I will write mass m1 into x2 of t minus m2 x2 of t minus m1 x1 of t. This is your f of t. Okay, this is when you are having two displacement. So what is the displacement here? So if I am going to write f of s, what should I write? m2 s square x2 of t, because this is displacement with, now here you have an acceleration. Okay, there you have an acceleration, minus m1 s square, sorry, this is s square x1 of s. This is after taking Laplace transform. Okay, this is about mass. Next is spring. Spring is represented as K. How it is symbolically represented like this, and it is represented as K. Okay, now I am going to fix this object. Spring cannot be used alone. It has to be connected to a mass. Without an object, spring cannot work. Okay. Now, when the spring is connected, this is reference point or rigid point, we will say it is fixed. Now, I am going to pull the spring with a force of f of t, and I will have a displacement of x of t. You can ask me, where is the mass? This is the mass. This will act as a mass, fixed body. spring is connected to that. Only then when you pull it, it will have the displacement. Now f of t is equal to k into x of t. This is the expression for f of t. Now what we have to do? Have to take the Laplace transform. Then f of s is equal to k into x of s is the expression for one spring if you are using. Okay. Okay. Now let me use two mass. See, now you have mass m2 and here mass m1. A spring is connected between it. I will call the spring as k, and displacement at this point is x2 and displacement at this point is x1. Now what will be the expression? F of t is equal to k into, okay, before writing this you should know the equivalent circuit, how to analyze this. See, I will say this is connected to this point. I'll have a spring and this, okay, I'll say k. Now this one will act as mass m1, this one will act as mass m2. Here I have a displacement of x1, here I have a displacement of x2. This is equivalent. I told a dot indicates mass. Okay, this mass is represented like this. Okay, now you write the expression for this. Okay, f of t is equal to k into, which is coming out first? Just an adjustment. Okay? By mistake I have written like this. So mass m1 is here, mass m2 is here, the equivalent circuit. This is x2, this is x1. Now my expression, which one is coming first? x1 of t minus x2 of t. Now what is the Laplace transform of this? F of s is equal to k into x1 of s minus x2 of s. This is the expression when I am using two mass. Now the last one is friction. I told friction is obtained by using a dashpot and it is represented as B. Okay, it is symbolically represented like this. This is my dashpot B. Okay, this also cannot be used alone. It will be used along with the mass itself. Here mass is there. Here I am going to use a dashpot B connected to a fixed object. When I am going to apply a force F of t, I will get a displacement of x of t. Okay, now when I am using like that, when there is a dashpot, then I have to use a velocity there. So f of t will be equal to b into, b is the dashpot, and dx of t. This dx of t will be the velocity. So it will be equal to f of t is equal to dv by dt, b into dv by dt. This can also be written like that because it will have some velocity, some opposing force it will give. The dashpot will give me the friction. That friction will provide some opposing force. That opposing force is given, we'll consider it as velocity. So dx by dt will be given as dv by dt. Now what you're going to do? Take Laplace transform of that. Then f of s is equal to b into s into x of s. This is the final expression for the friction. F of t, f of s for the friction. So we'll summarize. First one, mass m, mass is represented as m, and f of t is equal to, this f of t is equal to m into d square x of t by dt square, which is nothing but f of s is equal to m into s square x of s. Next, second one is your spring, represented as k. So f of t is equal to k into x of t, f of s. f of s is equal to k into x of s. Next, third one, dashpot, represented as b, which mainly it is considered due to friction. So f of t is equal to b into dx of t by dt. On taking Laplace transform, f of s is equal to b into s into x of s. So these three you should remember.